Today we are going to talk about ionic bonds. I told you about electronegativity in the last lecture. So it was the love for electrons. Here one atom loves the electron so much, it's so electronegative that it's not going to share the electron with the other atom, and it completely takes the electron from the other atom to complete its valence shell. Clear? If I say atom 1 and atom 2. Here atom 2 has taken the electron from atom 1. Now there is attraction between two atoms here, because the one which has given electron becomes positively charged and the one which has taken extra electron becomes negatively charged, and negative and positive attract each other. Clear? And because of this attraction, an ionic bond is formed between the ions. Positively charged ion is cation. Positively charged ion is cation. Cat, T, positive. And negatively charged ion is anion, N, negative. Clear? Okay. Anyways, for example, sodium and chlorine. Sodium has 1 valence electron in its valence shell, and chlorine has 7, and it needs 1 to complete its octet. Chlorine is highly electronegative, so it will completely strip off the valence electron it will snatch the valence electron from sodium, resulting in a positively charged sodium ion, negatively charged chlorine ion, both positive negative attracting each other, and what is formed? Ionic bond between these two ions. Clear? So this is the formation of ionic bond. One more thing, any two oppositely charged ions can come close to each other to form the bond, and it's not compulsory that the bond is formed, the ion positive and negative are formed because of giving the electrons to the other atom itself. Means it can be positive or negative because it has taken or given electron to some other atom also, and it became positive. Maybe chlorine has taken the electron from some other atom and it became negative, like that. So any two ions of opposite charge can form an ionic bond. They do not need to have acquired the charge by electron transfer with each other. Got it? The ions do not need to have acquired the charge by electron transfer with each other. Understood? See here. Sodium, earlier it was neutral, now it has lost 1 electron, so it has 1 extra positive charge, 1 extra proton. Chlorine, it has gained 1 extra electron, so earlier it was having 17 electrons and 17 protons. Now it has 18 electrons and 17 protons, so it is now chloride ion. Understood? Now, so the valence shell of chlorine is complete with 8 electrons and the valence shell of sodium is complete with 0 electrons. Okay. Actually, when sodium loses the electron from its third shell, now the second shell is the outermost shell, and this is complete here. So octet is complete. And for chlorine, the third shell, 8 electrons are there, so octet is complete. Understood? Okay, now the compounds here that are formed by the formation of ionic bond are called salts. You know the salt which you eat, table salt. See, in covalent bond, the atoms were in a fixed ratio, but this is an fixed number. Clear? If I say methane, there was 1 atom of carbon and 4 atoms of hydrogen. Clear? If I say O2, 2 atoms of oxygen. In ionic bonds, there is a ratio that sodium and chlorine will be there, but it's like a full 3D structure. The salts are often found in nature as crystals. of different sizes and shape, and each crystal is an aggregate of large number of cations and anions bonded together by the electrical attraction. Clear? And they are arranged in 3D lattice, 3-dimensional lattice. Clear? And there will be large number of cation and anion. So it's not like covalent bond. In covalent bond, there is definite size and number of atoms. Here, in ionic compound, what's there? There are not molecules. Clear? Here, if I say sodium chloride, NaCl, so NaCl will indicate only the ratio of sodium and chlorine 1:1. It does not indicate that it is a molecule. Clear? You can see here the green balls indicating chlorine and purple bonds indicating sodium. See, there is 3D lattice. Clear? You see here? Okay. Now you can see the different types of salts which we eat. Clear? Each salt that is formed by the formation of ionic bond is not edible. I am talking about the sodium chloride which we eat. But here you can see different colors. Primarily all these are sodium chloride. The different colors come from the trace minerals. Here you can see the black salt. It's so tasty. Black salt. But why is it black? Because of iron sulfide. You can see the pink salt. This is a picture from Kevra mine. You can see Kevra mine is in Pakistan. Kevra. Okay, so Kevra salt mine is in Pakistan. This is the salt mine. You can see the pink salts. Here you can see the salts of different sizes and shape which we have been taken out from the mine with the help of hammer. This means it's so strong that hammer and chisel are needed to crack the crystals. So ionic bonds are very strong in dry salt crystal. But what happens when you dissolve the salt in water? So the ionic bonds become much weaker when the salt is dissolved in water, because each ion is partially shielded by its interaction with water molecules. When we dissolve, it's partially shielded by its interaction with water molecules. Most of the drugs, medicines, they are synthesized as salts because they are quite stable as salt, and when dry and when you dissolve in water, they dissociate easily. See the pink salt. It is pink because of iron oxide. See the beautiful mosque made up of the salt inside the mine. See the dry salt crystals are very stable. You can see this beautiful pink salt. Now the sea salt. Okay, pink salt is pink because of iron oxide. See, different salts are there, and the main composition is sodium chloride. I am talking about different edible salts, and there are different trace elements which give different colors and different properties, right? Okay, so you can see this salt, sea salt. Okay, here in drying pans, this is picture of Tamil Nadu, this is from Thailand. Then you can see one crystal of sea salt. Here you can see the sea salt, and this pink color is not of salt, this is of halophilic, salt loving organisms that giving the color. Okay, anyways, then not all salts have same ratio. If I of cation and anion, means equal ratio of cation and anion. If I say MgCl2, this is a salt in which the ratio between magnesium and chloride is 1:2. Magnesium has how many lone electrons? 2 lone electrons in its valence shell, and it has to throw out both the electrons so that it completes its valence shell. Clear? So it has the tendency to become Mg plus 2, a cation with net charge of 2 plus. So it can form ionic bonds with two chloride ions. Clear? Then the ion word is also applicable to entire molecule that is electrically charged, not just an atom. If I say ammonium chloride, in ammonium chloride, you know ammonium is positively charged, and ammonium is positively charged, chloride is negatively charged, and here in ammonium one nitrogen is covalently bonded to 4 hydrogen atoms. Now this whole ammonium having one positive charge can form ionic bond with chloride ion. Okay, this much was ionic bonds. Thank you so much.